right. Algebra 3, Lesson 9. Oh, I forgot to send you guys the review. I will try to do that today. I am really sorry about that. What's that? All right. If that happens, email me. You know, hey, are you going to send a review? Okay, that kind of thing. Because I was here till like, I don't know, 7:30, 8 o'clock, something like that last night. I don't know why I didn't get it done. Anyway, what we're going to talk about today is we're talking about congruent figures. Congruent figures, just so I'm not standing around waiting for you to answer fairly easy questions. Congruent figures are figures that have congruent corresponding side lengths, okay, congruent corresponding angles. Okay, so talking about congruent figures, that's what we're kind of looking for. A lot of this is built upon premises that we get in geometry. We're just not that far in geometry yet. I actually think tomorrow, actually no, not tomorrow, it'll be next week. Probably if you're in geometry right now, probably the most important lesson that's going to help you out, not only in geometry, but in this class as well, is lesson number 12. So if you have a geometry book, I'd look at lesson 12, because that's going to tell you about some things where we have parallel lines cut by transversals, and we see a lot of that. Anytime we see a proof question, give me two parallel lines, I want to look for two parallel lines cut by a transversal and what that's going to give me. Okay, and we've talked about that a little bit up to this point. So when we're trying to prove something, we have an outline for it. Okay, I'm trying to find one of my writing pen things. Here we go. All right, in the basic outline for a proof is statement. Okay, we're going to do two-column proofs in here. Now in geometry, you learn about flow charts, you learn about paragraph proofs in addition to two-column proofs. In here, we are only working with two-column proofs, which is good news, okay? Because it's the easiest way to outline a proof. What always goes in as the first thing for our proofs is what we are given. What are they telling me off the bat? Okay, for instance, they tell me here BC is parallel to EF. Okay, that's my statement. Okay, my reason is that it's given. Okay, is that pretty easy? That's basic. Okay, the next thing, do they give me another given? Okay, BC is congruent to segment FE, given. Okay, now for this next part, I'm going to go ahead and I'm going to fill in, I'm going to use tick marks, I'm going to do everything to the illustration that I can do to help me prove what it is that I need to prove. So I'm going to go back to these givens and I'm going to show these. So BC, EF, those arrows show me that those two lines are parallel to each other, right? Okay, the next thing is that they tell me that BC, okay, is congruent to FE. So those are the same length. Okay, if we look in our book, we're going to learn some things about congruent figures where they concern triangles, and these are things that you'll want to know and write down. Okay, and we'll come back to this question here in a second. Okay, in order to prove that two triangles, in this case, are congruent, we have three postulates. Okay, one is side, side, side. If I can prove that three sides of a triangle are congruent to three corresponding sides of another triangle, I can prove that these things are congruent. Okay, so this is the side, side, side congruency postulate. Okay, you'll find these on page 68. Another one that we have is side, angle, side congruency postulate. Okay, so if I have something like that, I know that those two triangles are congruent. Okay, if I have side, angle, side, so side, angle, side, side, angle, side. And it has to be in that order. It just can't be any two sides in an angle. Okay, it has to go in this order. What you'll notice is that because A is in the middle, A is included. Do you guys understand what it means for something to be included? It's in between. I'm reading it as I go around. Okay? For instance, this is not an example of side angle side. Okay? I would read that as side side angle or angle side side. And one of the main reasons I know this won't work is because angle side side would make me cuss. Right? There's no ASS in proofs. Okay, you follow me? All right, so if you find yourself writing a cuss word as part of your proof, you've done something wrong. Okay, so we have side angle side. Okay, let's see, I believe, yeah, we have angle side angle. Congruency postulate. Okay, this is where I have two angles and an included side. Okay, something like that. Give that another tick mark. Okay, angle, side angle. Okay. And we also have, really, if I have, it doesn't really matter at this point. They have what they call angle, 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 side. And or angle, angle, side angle. Okay. Or, you know, it's not really any different than this. Basically, when we get to here, any three angles and one side. Okay, it doesn't matter where that side is. It could be side angle, angle, angle for all. It doesn't matter. Okay, that's not going to change anything. So by the time we get to these three, it's any three angles in a side. What is common about every single one of these? What? All of them have what? No, not all of them have three angles. In fact, the first one doesn't even have an angle. They all have at least one side. All right, because, and here's the reason why, is because if all I have is angle, 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 in similar figures, similar triangles can have angle, angle, angle. But I have to know that I've got a corresponding side that is congruent to a corresponding side in order to prove that these two figures are congruent and not just similar. Okay, so I have to have a side. If I haven't proven a side, I don't have it yet. Okay, I don't have a congruency statement. Okay, so do we gather this? We understand the principles behind this. All right, so let's go back to our original question. Okay, do I have a side? Okay, I've got a side, but do I have any angles? No, I don't have any angles. Okay, so we need to go about proving some angles, right? Or at the very least proving some sides, but we only have so much. Okay, can anybody tell me what we know from looking at this? They share, well, kind of, right? David's saying that I've got two lines coming across here, right? All right, when two lines cross, we form linear pairs, we form adjacent angles, we form vertical angles, right? Vertical angles are what's important here. Okay, can anybody identify any vertical angles? I can't, listen, D, I don't know when you say D if you mean this angle, this angle, this angle, or this angle. I don't know. You're not being clear enough. Okay, so how can I be more specific so I know exactly what angle you're talking about? All right, so you're saying you said BDF? E. Okay, so he's saying EDF. So angle EDF. Now, what do we know about vertical angles? They are congruent. All right, so angle EDF is congruent to what? Angle BDC, no, not BDC. CDB. Why is that order important? Because we have to have corresponding points to corresponding points. Okay? All right, so he's right, and what we're going to say is vertical angles are congruent. Okay? So to take that, take what he said and put it on the board, okay, we know this to this. So I have angle and side. I need, okay, I need at least one more what? I need at least one more angle, right? All right, the next clue comes from our first given. BC is parallel to EF, okay? I've got this line is parallel to this line. But what does EC do? Okay, let me show you where EC is because I'm getting a lot of blank stares. This is EC. This is this line. There's that line. Okay, sometimes it helps to see it as two parallel lines cut by a transversal. I'm guessing that nobody in here knows this. Okay, let's come over to another page. Okay, I'm going to draw you two parallel lines cut by a transversal. Okay, we've got angle 1, angle 2, angle 3, angle 4, 5, 6, 7, and 8. Okay. If I'm looking at this, I know that angle 4, okay, if I'm telling you here, these two lines are parallel. One of the first things that we have is we have alternate interior angles are congruent. Alternate interior. Okay, that means inside the parallel lines on opposite sides of the transversal. In our case here, that would be angle 4 and angle 5. Okay, also angle 3 and angle 6. Okay, those are alternate interior angles. You follow me? Okay, next one on our list. Okay, we can also have alternate exterior angles are congruent. Okay, can anybody name any alternate exterior angles? That means opposite sides of the transversal outside the parallel lines. Go ahead, Mike. 1 and 8. Okay, I think I heard somebody whisper it. I just couldn't hear you. Okay, somebody louder. Another pair. 2 and 7. Okay. Okay, and kind of trying to hold on to that. All right, so we've got alternate interior, alternate exterior, and then corresponding angles. Okay, corresponding angles would be like 1 and 5. Do you see how this angle 1 and this angle 5 are the same shape? So that's angle 1, angle 5. Okay, anybody else see a set of corresponding? 2 and 6. Okay, anything else? 1, 5, 2, 6. What else? 3, 7. What else? 4 and 8. Okay, so whenever they tell me that I've got two parallel lines and I can see a transversal cutting it, I want to be thinking about these three things: alternate interior, alternate exterior, and corresponding angles. Okay, this is lesson 12 geometry. All right, so let's come back. All right, do I have anything like that? Okay, where? What? Angles C and E. Okay, so let's be more specific. Let's say angle BCD is congruent to angle what? BCD, so what? FED, angle FED, okay? Now, the long explanation, and my marker's too big and I don't have enough space to say it, but this is what it should say. Two parallel lines cut by a transversal have what? What are these two angles to each other? On that list of three things, what are those two angles? Alternate exterior. So they're outside the parallel lines. They're alternate interior angles. So what I'm going to shorten it to is I'm going to say alternate interior angles are congruent. Okay? So that gives me angle, angle, side. Do I have anything for angle, angle, side? Can I stop there? All right, I can't, right? I don't have an angle, angle, side, do I? Okay? But here's another thing that we know. Because every triangle has how many degrees? 180 degrees, right? That if I know that this angle is congruent to this angle and this angle is congruent to this angle, do I know by matter of fact that this... What on earth just happened? Okay. Let's... Okay. What I learn is that this angle has to be congruent to this angle. So what we would say here is angle EFD is congruent to angle, let's see, where we're at, CBD. And the reason for that is if two angles, then three angles. That's what it is. If two angles, then three angles. If I know that two angles of a triangle are congruent to two corresponding angles of another triangle, then their third angle has to be congruent because there's a limited number of degrees. In fact, there's an exact number of degrees. Okay? And at this point, if I had not done the vertical angles, I could have stopped here and done angle, side, angle. But because we went further, we're going to say angle, 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 or actually we're going to say triangle. Sorry, we got to do our statement over here. So we're doing triangle, BCD, is congruent to triangle, FED. We're going to say angle, 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 side, congruency postulate. All right, so what proofs do is they take everything that you know and they ask you to put it together, okay? One thing after another thing after another thing, and not just saying, well, this is true, all right? But how do we know that it's true? How can I prove it, okay? We're asking for the proof. Questions about this? Okay? Hopefully we're taking notes, right? My suggestion is draw the picture, draw it out. If you haven't written this proof, right, in the notes that I've given you, right, you are missing opportunities. Okay? You will get the video, but you're not getting this document where you can just sit there and look at it. Okay, without just hitting pause. All right? Do you have enough information? What time are we out of here? 10:51. Okay. All right. Let's erase this. All right. We probably have time for one more proof. You guys have the document, right? Why don't you pick one? We got 2. I think 3's on the, yeah, there's 2 there. There's 3 and 4. So 2, 3, or 4. What do you want to look at? 4? 4. Okay. So 4. Let's see. R is the midpoint of MS. TR is perpendicular to MS. If you outlined a proof that shows that TM is congruent to TS, which would not be used? Okay. So let's start off here, because we're not actually outlining the proof, we're just saying what isn't going to be used. If R is the midpoint, I would be able to say that MR is congruent to RS, right? That would be one of the things that would go in my list. My statement, my reason for that would be definition of a midpoint. A midpoint divides a segment into two congruent segments, okay? So we've got that. R is the midpoint. We could say that these are perpendicular, correct? All right. And notice that TR is a shared side. Is that correct? TR is shared on both triangles, correct? So you're seeing that right there. That is what we would say TR is congruent to TR. That's the reflexive axiom, right? And what I would have at this point is I would have side, angle, side, side, angle, side. Does that make sense? Okay. So if I look at that, afterwards, after I've proven that the two triangles are congruent, now I can say that their corresponding parts are congruent through what is called CPCTC. All right? And this is important whenever we're talking about, hey, here are these two figures, but I don't want you to prove that our ending part isn't their congruent. Our ending part is, I want to know that this part is equal to this part. And so you'll want to know what this is, CPCTC, which means corresponding parts of congruent triangles are congruent. Okay? If I'm trying to prove that one part of a figure is congruent to another part of a figure, almost every single time I'll have to prove first that the two figures are congruent to each other, so I'll need a congruency statement. And then finally, after I've proven that those two triangles are congruent, I can say this part corresponds to this part. They are congruent through CPCTC. But I cannot ever, under any circumstances, use this before I have stated that the two triangles are congruent. Do you understand? Because this says they are congruent, therefore these parts are congruent. I can't say these parts are congruent if I don't know that the two figures are congruent. It will be wrong every single time if you use this too early. Okay? Does that make sense? All right, so let's come back. All right, so you'll notice that we outlined A, so we would use that, okay? B, we're probably going to use, let's see, they say we want to prove this, right? And after we've proven that the two triangles are congruent, we're going to say TM is congruent to TS by CPCTC. Okay? So we're looking down at these parts. Am I going to prove that these two triangles are congruent through side, angle, side? Yes or no? Do I have side, angle, side there? Yes. Side, angle, side. All right. Do I have angle, side, angle? No. So the part that I'm not going to use, would not use in my proof, is that. Okay? I can't use angle, side, angle there. All right. You guys feel like you have enough information to be dangerous? All right. You guys are more than welcome to ask as many questions as you want. Okay? This is hard. These are hard. Okay? You have to do a lot of critical thinking. Okay? It's not add, subtract, multiply, divide. Okay? It's tough stuff. So take your time with it. Go back and hopefully you've taken some notes and you can look at those, all right, for some hints.